We begin relational algebra. This is a lot like SQL, but SQL is practical. It's a programming language. This one is more of a theoretic approach. So these are just statements that you just write on paper, but they cannot be used as an actual program. So relational algebra is a theoretic language. Okay, it is theoretic language which is used to model database data. Okay, so algebra. Yeah, so relational algebra is more theoretic. It's theoretic and it is used for uh, modeling. It is used for modeling database data. This one it differs from SQL. It differs from SQL because SQL is practical, while relational algebra is a theoretic. Meaning with SQL, you can actually run a program. Algebra, yeah, relational algebra, you can't. It's just it's theoretic. It is basically theoretic. And so you just use it for mapping databases that you wish to create. Then the operators that I use for relational algebra, okay. So the relational algebra operators, relational algebra operators, relational algebra operators. So we shall look at two for now. So the first one that we have is code selection. First one that we have is code selection. So the first operator that we have is known as selection, and it uses this symbol. The symbol looks like this. This is known as selection. So selection is used for picking out specific records from an application. Okay, for picking out specific records from a relation. So like the way we have that table, a relation is a table. So the way we have that relation there, that table, if you say you want a record for Fred, that means you have to apply the selection operator because it will just basically pick out a given record from a table, a relation is a table. So selection, that is the symbol that is used. Okay, that is the symbol that is used. Remember, in SQL, you have select. You have a statement called select. Select this from that. Yes, you have that operator. The second operator that we have in relational algebra is called projection. Okay, projection, which is used by this pi symbol. It's the same one that is used in math, by the way. Pi symbol. So projection. So the projection symbol is used for picking out specific columns from a relation, okay? For picking out specific columns from a relation, okay? This one is used for picking out specific columns from a relation. So this one is just for picking out specific columns from a relation. So projection is basically used for that particular purpose. So these are the operators that we have in relation of algebra. So you have selection, which is used for picking out specific records. In the questions there, you can see we have first question, which says display all students whose course is BIT. Display all students whose course is BIT. So obviously you're looking for records. You are looking for records, and these records specifically should contain BIT as the course. So you're looking for specific records or students, who are the students doing BIT. So these are records that you're dealing with. So you have to write a relational algebra statement there, which is going to pick out the students that are doing BIT. Okay, the ones that are doing BIT. So there you need to utilize the selection symbol. For now, let's copy the definitions and the operators, then we can solve the questions. Have we copied the definitions? Have we copied? Have we copied the
Yes.
definitions?
Yes, I've copied.
Okay. All right, we've copied the definitions. Let's solve the questions now. Okay, so first we are saying that we need to display all students whose course is BIT. So what we are looking to do here is to display records, right? Records, we're talking about rows. So you say, okay, this student whose ID is this is the one taking BIT, something like that, right? So there we need to utilize the select statement, okay? Because when it says select all student, it means details for every student. That means that's a full record. A record is basically all details that are concerning a particular student. So there we need to utilize the select statement. So the select statement has been given with the symbol, that symbol which is known as a theta. That is from the Greek alphabet, theta. It's called theta, that symbol. So if you're wondering, this symbol is called a theta, okay, which is part of the Greek alphabet. So you are basically selecting. So in terms of when you say whose course is BIT, which field or which column is keeping the courses for each student? Which column is keeping the details for the courses taken by each student? Which column?
Course.
Course, right? Yeah. So there you simply say select, you place that symbol. So you say select course. Then there what you have to say now is you say course equals to, you're looking for BIT, right? So in single quotes, not double quotes, please. So you say BIT, okay? So you say select course equals BIT. Then in brackets here, you are going to specify the name of the relation or the table, and the table name there is student. So you say from student, exactly the way it has been given in the question. So you can see there the name of the relation student. We have provided that one here. Okay, so firstly, you start with writing this select symbol. Then you say, what are we looking for? We're looking for whose course is BIT. So the courses are falling under this field, which is course. So you write course. Then there you say equals. Then what course are you looking for? You're looking for BIT. Then you specify from which table is all this information coming from? It is coming from the students. So that is the select statement. That's how it is supposed to be written for relational algebra. Any questions, please?
Should we put terminate or just like that?
No, we do not put terminate with relational algebra. There is no need for termination. So no, that one you do not use any terminations on the SQL. So no terminate, no semicolon. Is it clear there?
Let's proceed.
Display of students whose age is above 25. So there you again place your select statement. So you simply say select, then you're looking for age. So the column that is containing age there is age. Okay. What is the criteria? Saying what age is above 25, right? So instead of you saying equals, you have to say age is greater than 25. Okay. Age is greater than 25, of which you also specify that all this is coming from the table called student. Then that's pretty much it. You bring in your statement, your relational algebra statement to display your students whose age is above 25. What about whose course is SCCA? How should that one be written? Whose course is SCCA? How do you think that one should be written?
We are just going to write the way it was written on number 1. Theta cos is equals to SCCA in single
Yes,
quotes, and
yes,
student in brackets.
yes. So course equals SCCA. Yes, SCCA. Then you place the name of the relation, which is student. Yes, accurate, yes. Just like that. We can copy the solutions. Let's also ask where we're up there. We can log back in so that we can continue and use the same link.